its intelligence. The average IQ of Chinese is 105. So that makes them smarter than the average American and European. Now, of course, regions differ over a whole continent. The Germans, for example, have an average IQ of 105, so they're a match for the Chinese. But the Chinese are using their intelligence, well, the politicians, to stay in power. There's an ancient culture, 5,000 years old, and their instinctive, cultural, historical response to any challenge to the leaders, the dominating powers, authority, is just brutal suppression. They just kill people. So sooner or later, within the decade, I feel, before 2020, China will go through its democratic transition, and I hope the leaders have enough, the next batch of them, and they'll be switching this year, 2012. I hope the next batch have sufficient intelligence and vision to realize that their days as a single power are numbered due to the inevitable rise of the Chinese middle class. There's somewhere between 100 and 200 million middle class Chinese now. By the end of the decade it'll be about 500 million, and they will travel. They will see 90% of people living outside China live in democracies. 90%. So that makes China the big, bad, backward exception. And these middle-class Chinese international tourists will realize that, and the rest of the world will look down on them, look down on Chinese for not being democrats, for not living in a democratic system. And those travelling Chinese tourists will feel it. They will feel that they're looked on as inferior for not being democrats, and that will get them thinking. As I say, as a globist and a multicultural person who compares and ranks customs, related customs across various cultures, as a multi, I culture bash. Culture bashing is a necessary step to the formation of a global state, a culturally homogenized, essentially global languaged global state. So culture bashing is useful. So the Chinese listening, I hope you take these opinions to heart, because you will be caught up in it. I hope the transition, when it comes, will be peaceful. I hope the new batch of Chinese leaders have enough vision to see it's in their self-interest to make a smooth switch, to do it wisely and plan for it, so that it's smooth and non-violent, so there are not millions killed in a major civil war, the way that's happening now in Syria, but on a Chinese scale, which is frightening. So that the party, with a change of name, a change of philosophy, but more or less the same people, with the corrupt ones thrown out, of course, that they may even win the first election and stay in power and continue to give Chinese people the world's highest average economic growth rate, because the party is doing some good things. Okay? So keep the good things and throw out the bad things. Throw out the dictatorships. Get rid of the Lao Gai, the Chinese equivalent of the Gulag. Effectively prisoners, political prisoners, slave labor camps. There are over 1,000 of them in China today, 2012. According to Harry Wu, he spent 19 years of his life in a Chinese Lao Gai, hates the party, moved to Washington and set up a Lao Gai museum in Washington, D.C., capital of America. And he claims, he does research on this, there are over 1,000 of these slave labor camps for political prisoners in China today, with somewhere between 500,000 to 2 million political prisoners. So, it just stinks, right? So all that has to go, and it's only a question of time. So anyway, yeah. I'm a political animal and a scientist. Okay. All right, back to the nitty-gritty. We on this board and the next, we will be talking about examples. We were doing walkthroughs, effectively, of, on this board we'll do two and a bit examples of Turing machines in action. These machines, these Turing machines, these TMs, will decide a language. In other words, that means from the previous board, previous session, I think, to decide a language means whether to look at it, examine it, and to accept it or reject it, but no looping. Okay. It's a decider. The TM that's being used is a decider, according to definition of Sipser. A decider is a Turing machine that takes a language and either accepts it or rejects it, and that's it. Yeah, no third category, no looping, right? No infinite, never stopping. And we'll be given 4 different languages, and we will accept them. So, okay. So the first, now we've actually, slight confusion. We've actually discussed our first Turing machine, just in giving a general notion of what a Turing machine is, and that was M1. 1 for the first machine, M machine, Turing machine. So our first real walkthrough will be with M2 because it's our second. But oddly, the second example we'll give this board is M1. So we go back to M1, but M1 was it's a bit more complicated when it comes to the actual transition function and so forth. It's a bit more complex than this one. So for didactic reasons, we'll start with this one. All right. So the task is to describe a we'll give a quasi, almost, yeah, we'll give almost a full description, formal description of this Turing machine, M2. In other words, we'll give the details of the 7 tuple of the machine. Now I'm hesitating because Sipser as well, will not be writing out formally all the transition rules. But implicitly, those transition rules are present implicitly on the state diagram that will come in the next session of this machine M2. You'll see the state diagram. And with the state diagram, you can look at the labels of the transitions and get the transition rules from them. So implicitly, all the details are there for this example. The second example, there will also be a state diagram, a state transition diagram, but not complete. Certain states are left out. Otherwise, the diagram would get too cluttered. Now, I guess the key word, almost the general theme, or the general idea to come out of this board and the next is, well, the general impression that you'll get, I guess, is that Turing machines are complicated, right? Like fiddly, lots of details, and tedious in some ways. So it's not surprising people tend not to, when they're describing Turing machines, they tend not to give all the details. They just sort of give you more the overview and enough details that you can understand how it works, but not the, they don't dot all the I's and cross all the T's, so to speak. They don't do everything. All right. So with that in mind, let's start the first one. So we're designing a Turing machine M2, and its task is to decide a particular language. Now what does it mean to do decide? That means that it accepts or rejects. So, well, here's the language. So we want our machine to accept all strings of this form in this set. In other words, in this language. Remember, a language is just a set of strings. And the form, the description, if you like, of the type of string, it just consists of a whole contiguous sequence of zeros, the symbol 0, right? Here. And if the number of those zeros, when you count them, is some power of 2, 2 to the n, so 0 to 2 to the n. Remember, this is just shorthand for saying it's a sequence of 2 to the n zeros. Right? Just so the number of zeros in the input string, if it is a power of 2, like there's 2 of them, or 4 of them, or 8 of them, and so on, okay, then that string belongs to the language A. Okay, and your task is to design. Well, actually, we'll be analysing here. When the time comes in the problem session, you will be designing Turing machines, and as usual, design is an art. Okay, but this will give you some a feel, some experience on how to analyse the machine, and you'll pick up techniques that will help you in designing Turing machines. Okay, so that's the task. Have a look at the string. Count, well, if the number of zeros, the symbols, 0, in that string is a power of 2, 2 to the 1, or 2 to the 2, or 2 to the 3, whatever, so 2, 4, 8, 16, 32, 64, ... then that string belongs to the language. So design a machine that can decide that, whether it is or it isn't. Each string, any string of, put it this way, any string of length that is a power of 2 will be accepted. And any string that is of length that is not a power of 2 will be rejected. So when it's only accept or reject that the machine is doing, that machine, that Turing machine, is said to be deciding the language. Okay. All right. So now, given the language and the task, I guess the next thing is you need a strategy, like the high-level strategy. Like and now this sense of when you